Okay, now it's live streaming.
Okay. A very good morning to one and all on this extremely auspicious day, the Technology Day, that the country celebrates with great fervor. On behalf of the management of Nitte, deemed to be university headed by the Honorable Vice Chancellor, Professor Satish Kumar Bhandari, I have great pleasure in welcoming all those who have registered to hear our august guest and speaker for the day, Professor Gurumurthy. A little bit about Nitte University would not be out of place at this point of time. We are a deemed to be university, making strides in education and healthcare with the prime vision of developing a humane society. I would also like to inform that our university is graded A+ by the NAC, and as a center of excellence, we expect to impart quality education and generate competent manpower for the times to come. And all this is necessary for facing the social challenges that not just the country, but the world is facing. And towards this, even on an international platform, we have been recognized by the QS India ranking to be in the band of 56 to 60 during the year 2020. And more recently, the Times Higher Education has ranked Nitte deemed to be university among the top 300 of the world's university. Well, all this is only to ensure that we climb higher on the ladder, trying to do better, rather than becoming complacent with what we have been, but more to showcase what we are capable of doing. The Department of Science and Technology set up the technology enabling centers in the country more with the kind of theme that this year's Technology Day holds. The nation is in the process of translation of bench work research to technology, and this is being promoted for sustainable development. And to foster this, the Department of Science and Technology has set up 10 technology enabling centers at this moment, who have the prime responsibility of bringing research to the masses and looking at providing solutions for social challenges through use of science. Now, the DST Tech has set up, of course, state-of-the-art networking centers, but the prime objective is to create an ecosystem that enables technology development in the universities, that will provide a platform to network with premier national institutes of the country, the laboratories, national research laboratories that are there, and through scientific interventions, address the local needs. All of this, of course, is for sustainable solutions. Our own Technology Enabling Center has also been trying to do the little bit, and I'm very happy to put on record that our executive committee member and advisor, Professor Gurumurthy, the guest and speaker for today, has been also advisor to our tech. And we hope with his advice, more with, I should say, an expert advice coming out of a lot of experience, will help us forge in what we attempt to do. I would like to introduce Professor Gurumurthy on this occasion. An extremely erudite professor at the Indian Institute of Science presently. His early education was at the Indian Institute of Technology, Chennai, called, of course, Madras earlier. And then he moved to Pittsburgh for his master's education and PhD also from Carnegie Mellon University at Pittsburgh. Following that, of course, he has been involved in teaching at the Indian Institute of Science, and a position that we are very proud to note that he holds is as the vice chair and of the global product development for the whole life cycle from 2009 to the present. And a humble gentleman that he is, he does not probably share his CV because I think he believes in a lot of action rather than merely speaking a lot about him. But, I know for all the audience who may know or who may not know, it would be important to realize that he heads the Innovation Center and works towards achieving the goals at the Indian Institute of Science. And he is a visiting professor to Stanford University and also to the University Luminaire at Lyon in France. And I would say that he has a number of patents. He also has a number of technologies that he has transferred. Now, when we talk about Technology Day, having a gentleman of this stature is more important than having people who would be talking all the theory about technology or of patents or the way to go about. Theory knowledge is all available. Today, information is available at the fingertips and just the click of a button. But having someone speak with the experience that they have got through the various positions that they have held, through what they impart to the young and the handholding that they would do for anyone who approaches them, makes us realize that we got probably the best gentleman to address today's Technology Day. A little bit about Technology Day. Like the Science Day, which is celebrated in honor of Sir C.V. Raman, who, of course, generally all important days are due to the birth anniversaries of people, but Science Day is due to the discovery of the Raman effect, and that day holds great importance for scientists. Likewise, the National Technology Day that is celebrated is because of the technological advances that is being celebrated year after year, but it began maybe very early, maybe in about 1974. The spark of it was when experiments were done on nuclear power showcasing India. Now, when it was done, and Prime Minister Indira Gandhi, of course, with the scientist who was heading it, Dr. Ramanna, when they were involved, they did, yes, carry out the Pokhran-1 blast in Rajasthan, okay? At that time, it was called, yes, Operation Smiling Buddha. And when we successfully did it, Dr. Ramanna spoke to the Prime Minister and said, the Buddha smiles. But it took a whole decade or a little over a decade when in 1998, the Pokhran-2 blasts were all planned and India entered the elite group of nuclear developed nations. And that Pokhran-2 blast was, the whole scientific thing was by a group of eminent scientists led by Sir APJ Abdul Kalam. And the Prime Minister, the then Prime Minister, Atal Bihari Vajpayee, was, of course, as the country's leader, very happy at the success of what was carried out. But for the 15 years from the first blast to the second, these group of scientists and politicians worked in a very coordinated and cohesive manner, but without too much noise. And probably the best thing was keeping the press out during that time, so that even before the success is seen by everyone, a lot of press statements sometimes can prove to be disastrous for people who are working. And therefore, when the second Pokhran blast was carried out, which was called Operation Shakti, Sir Abdul Kalam called the Prime Minister and said, the Buddha smiles again. The success of it and this entire Technology Day celebration from 1999 started to honor all of these people and scientists as a community. When I say scientists, everybody who does science, it may be a teacher, it may be an engineer, it may be from any field of science. But of course, science with all the development aspects, science for society. And India has been one of those countries that has always used all science, including nuclear sciences, for the benefit of humanity. Now, why was it called the first time Buddha smiling? Smiling Buddha was the code given. That is because it happened on Buddha Purnima Day. Now, when it happened again, Buddha really smiled, and the success of it can be very well understood because television, films are a very important media for disseminating the very best to all of the people. And maybe everyone who doesn't understand what Technology Day is all about can actually watch the movie Parmanu. It is, I would say, about 90% fact that has come about it, except that all the leaders who partook in all of those operations are not the actors or actresses there, okay? But they have been, of course, supplemented with people who did that task, being trained the way they have to do it, okay? Now, there are innumerable quotes by Sir Abdul Kalam to mark this particular day. And I think we all stand inspired by whatever was done that day. And I think we are very grateful to this country. I think in 2002, Karunasagar got the Technology Day Award, and in 2015, when I got, we feel the joy of what we have done as a community, you know, the students, the postdocs, everybody who joins the projects, works with us. When it is recognized by a government, that really is just a pat to say, yes, there's a lot more that is possible to be done in this country. And we have, of course, talents galore. And the ecosystem in the country is such today that you want to do something, there are not powers that are going to hold you back. And therefore, there would be no excuses to say why we can't do or why we don't do. In the past, maybe we had. But in the last 3 decades, I think India is forging ahead. And the Technology Day celebrations are something that hold very dear to all the young and the scientists at every age that are being guided by seniors to give their best to society through intervention. Well, with that introduction, and I think we are honored by the presence of Professor Gurumurthy. He has been very humble. We wanted to very much have him here, but you know, the great people, the humble people are wanted everywhere, and he has his own events to attend to this afternoon, which is why he is not there in person here. But Corona has taught us how no reason or the absence of a person in the physical form can hold back any activity that we want to carry out. And therefore, sir, I thank you very much for kindly agreeing to be here. I thank the Nitte management for and the Vice Chancellor particularly, who was very, very keen to have. But there's a very urgent task that has come about, which is why he's unable to be here. Otherwise, he never misses to be on any event, especially when a guest of your stature is there. I thank the Government of India, the IISc Technology Enabling Center, and more importantly, our speaker for today for making it possible and memorable for all of us. Over to Professor Gurumurthy for his much-awaited talk. Thank you.
Thank you very much for that very warm welcome and wonderful introduction to the origins of the Technology Day. I think that needed to be said, and I'm very glad that you laid out the background in which this whole thing happened. Let me share the screen so that I can start the presentation. I would have loved to be there. I have been there earlier, but this time, as I said, it's just that today there is another event here that we are doing. So that's why I could not travel, but I'm very happy that I can be with you through this, through technology, as it were. And so that's a very nice thing. So I thank the organizers, the DST Tech there, Dr. Karna Sagar and Dr. Karna Sagar for inviting me to be a part of this event. I think to that wonderful story that Dr. Karna Sagar mentioned about the second Pokhran, I would just like to add one thing, that this second event was truly, a symbol of the maturity and the technological chutzpah that the Indian, establishment showed, because the US, was upset, and as you know, there were sanctions that followed. But the truth be told, I think they were not so much upset by the fact that we did it, because there was appreciation that we did it because of the neighbor up north. But the reason why they were upset was because their intelligence agencies could not get even a whiff of what was happening. The fact that despite all the advances in espionage, information gathering that they had mud on their face as far as this event was concerned. And it was done through a very ingenious trick, as ma'am mentioned. If you have seen the movie, some of it is revealed, but I would urge all of you to sort of go through that, either through articles that have been written about it or the movie itself, because it shows how, with the application of mind, you can trump any advancement in technology if you can give enough thought to it and find the weak link. So I think it was a story that needed to be told, and I thank you, ma'am, that you mentioned this so that everybody is aware of it. Okay, so the task given to me was to talk about the translation, translation of work done in the academic institutions and the research labs to the marketplace, which is one area where we as a country have been rather weak. And so I am going to plan to address that, and that's why I've given the title of Innovation by Design. And I hope I'll be able to justify both the title and some of the things that I say by the end of this lecture. And I have to start with this buyer beware, because one is always hesitant to preach. And but the point of the matter is that everything I say is sort of backed up by some, formal study, careful study, and some experience that we have had here in running both a design department as well as an incubator, and working with industry to run a design service bureau for them. So I hope that I can claim exemption from this caveat emptor. So first, let me make this distinction, because quite often, these two terms, invention and innovation, are sort of used synonymously, and that is not quite correct, right? So invention is the part where the real scientific or the design or the innovative creativity actually happens, right? And the economic impact at that point in time is actually not addressed too much, right? It is innovation that takes that responsibility of taking a very creative solution and invention, as it were, into crafting it into a business model that results in success in the marketplace, right? And so that is something that we need to keep in mind, that not all inventions are innovative, right? And vice versa, not all innovations may be very inventive, right? And the goal, of course, here is, in some sense, success in the marketplace. And if it is driven by a creative, science or technology, then that is icing on the cake. So here is an example that I hope will illustrate the point, right? I mean, you see this design of a spoon that can be attached to your iPhone so that, your consumption of the content on this phone is uninterrupted, right? Versus the iPhone itself, right? As a smartphone, as a product. And clearly, the impact and the innovation is much more in the case of the phone itself, rather than this attachment that is quirky at best, and a waste of effort if you're very, very critical of this, because any design student or user who would like to use this can find out so many flaws in this. As you can see from this picture, that while the device is being used, you're hardly going to be able to see the screen, right? That's the nature of the eating process. And therefore, this invention is not going to be able to make it. Right? In India, we have had some, what shall I say, very successful examples of innovation or innovative solutions. They may not have all been based on very strong science or technology, but they've had some innovations. The first one on the top is the Sumit Mixie, right? Not many people of this generation might know, but this was the first Indian product that almost single-handedly stopped the import of mixers and blenders and grinders from the countries outside, Molimix and some of the other makes, Philips, etc., who used to rule the roost. And this company, by actually right-sizing the motor rating, that was the innovation that they brought in. They figured out that the Indian cooking needs more endurance and more heavy-duty drives. And so they chose the right motor, and that was able to address the needs of the Indian kitchen. And this product became very, very successful. The sachet is another example. Now, of course, it has become a little bit of a bane because of the waste issue. But nevertheless, as an innovation, it has its place, that it innovated by providing the product at the right quantity or the right size. Right? They found and they cracked this problem that while the rural areas, the poor areas, these products were not being sold, but that is not because that they did not want them, or they could not afford them. It was just that they could afford them in a different quantity. They would not mind spending 1 rupee per week, right, once a week, and then not have any leftover inventory, than spend 60 rupees on a bottle that they would use maybe over a period of a year. Right? That simple market intelligence led to a very innovative packaging in the form of a sachet, which was for single use. And that made a lot of products, affordable and available to a market that was hitherto not served. And so therefore, this is another example of a very innovative solution. Of course, the best sort of design success story that I believe in India, I mean, very indigenous to India, I should not say India, but very indigenous to India, has been the evolution of the wet grinder. Right? All of you are, maybe the younger ones perhaps have only seen the one at the bottom right and have not seen the evolution from the top left. Right? But that is the progress that has come through design, that, what used to be a very cumbersome and very, severe effort on the part of the people who use it, mostly women, unfortunately, in those days, right? To the slick device that, even modern kitchens would not hesitate to have on their countertop, right, is a long way indeed, and is a tribute to, the Indian industry and the design community in that industry. Right? And incidentally, the first transition to an automated product was done because the designer was so moved by the effort that the women in this house had to put in, that he built this device. And then, since then it has been improved upon. And today you have this slick device that can compete with any similar devices that the world can throw at us. So the first lesson that I would like to start with, right, and that is from history. It is not my lesson, but it is from history, is that in innovation, you don't have to be the first off the post, right? And if ever you have doubt that, how can this be true? The first guy would crack the market, right? These three examples should, give rest to all those worries, right? The middle column in blue are the companies that actually developed the product first, right? And the ones in green on the right column are the ones who actually made the money of the product, right? So the X-ray scanner was actually developed by this company called EMI, but bulk of the money in the medical field was made by GE, right? VCRs, again, this is a product that probably the present generation does not even know of, but it was first brought to the market by this company Sony through Ampex, but the bulk of the revenues in this product and the market share was cornered by National Panasonic, right? Mouse is an example that all of you can relate to, right? The company or the lab that did that, right? PARC was the research arm of Xerox Corporation. They invented the mouse, and they have the patents on the mouse. But as you know, the money has been made by the Apples and the Microsofts and the Logitechs of the world, right? And of course, if anything else does not convince you, then the last statement on this slide should convince you that Google was not the first search engine to come into the marketplace, right? You can go back and search. There were search engines from my own alma mater, CMU, and several others that were in play in the late 80s. But turns out that Google was the most successful, right? Even though it was not the first search engine. So just to sort of keep the discussion and give some focus to the discussion, I present a scorecard from our own department, right? We have been training about 20 students a year for roughly the past maybe 16 years. Before that, we were much smaller, about 8 students a year. So you can say that we have touched about 500 students so far, right? And they do this design project at for a year, towards the end of their academic program. And if you look at the outcomes that we have generated, the students have generated under, with help from their faculty supervisors, about 55% have been patentable, right? And quite a few of them are in process of being patented, right? So that's one scorecard, right? That we have 25 patents, 55 applications pending and so forth, right? But if you look at the transition, the more useful transition, this is like writing a paper that nobody reads, right? I can keep claiming I have 100 papers, but there is only one paper that somebody has read. Then my real impact is only on that one paper. And this is the same thing is true with products and patents as well, right? You can keep saying I have 50 patents, 100 patents, but who is using those patents, right? And that's the key. And if you see that, then, we don't look that good, right? We have licensed about 6 so far, and 3 are in some stages of technology transfer. Of the 9, if you include the 3 as well, so of the 9, 4 actually have now entered the marketplace, and 3 are, fortunately generating revenues, today for the company that licensed them, right? So if you look at it, right, from 200 possible designs, right, to about 3 that are generating revenues, it's not a very happy story, right? And so, what is it that needs to be done was the question that we asked. And so one of the things that, everybody immediately points out is that you choose products that are not driven by business considerations. And, and it could be so, and we will take this argument and we will come back to this in the course of this talk. But certainly that could be one of the reasons, but I do believe that the reasons are elsewhere, right? So that forms the context. And there's another one that, and one of the things that we want to sort of address today is that what happens when you try to take something that is done in a lab and, try to take it into the marketplace, right? And the main challenge is, of course, all of you would have heard this term already, Valley of Death. And there is a small story at the bottom news item in smaller print. Essentially it tells the story of the point it makes is that throwing money at this alone has not helped, right? This is a company that made an apple sorting technology, an apple picking technology based on vision and robotics, right? So very high tech. Labor is very expensive in the US, so it seemed like an ideal fit, right? And but they raised a lot of money. You would see the number somewhere in the article. Yeah, there it is, $10 million, right? And some more money from some other sources. So it is not that they did not have resources, right? And yet the company could not succeed because they needed more money. This money was not enough, right? And therefore, that's a key thing to sort of keep in mind, that the transition, from what you have in your lab to what you need to have when you want to sell in the marketplace needs significant resources, especially if it's a technology-oriented product. An app on a phone may not need this kind of an investment, right? So that's the lesson here. An interesting aside, though, I must say to this story is that, soon after this thing happened, maybe about 2 years later, one of our own startups, students from CPDM, they actually made an apple plucking machine, which was not vision based. It was only meant to enable the farmer as a productivity aid. And they were able to make some inroads into this market and sell some of their apple pluckers to the same Washington State, association that is referred to, right? So, as I said, sometimes very intense technology is also not required, right, for this. So you mentioned, see the reference to some technology readiness level. So let me just quickly, so that everybody is on the same page. Most of you would have been aware of this scale, right, which was first put out by the Aerospace Agency in America, right, and it essentially traces the various stages through which technology has to mature before it can be a product in the marketplace, right. Typically, right, if you have good students and good facilities, academic institutions would probably not go beyond TRL4. They would probably hover around 2 and 3, where they might be able to just establish feasibility. But if resources are there, maybe they have some project grant, etc., and the students are dedicated, then it is possible to push it to a POC in the lab. In a lab environment, you can have a working product, right? And the challenge that was mentioned in the previous slide is going from this TRL4 to about TRL8, where you are able to take the same product, and put it in the actual environment for use and show that it works. And that transition, is huge, right? Because not only do you have to have one prototype, you have to sometimes have multiple prototypes and have them tested. Because before you can put it in actual use, there are regulations that will demand that it has to go through some testing. Nobody can just take some product and test it, with people, especially medical, food, all these spaces. You cannot just go and say that, okay, here is a product, please use it. That cannot happen, right? And so that's the kind of scaling. And our concern also today is this transition from this blue to the red levels that shown here, right? And if I sort of stretch it out the other way, in the other axis, the valley of death becomes obvious, right? That the academia is very active in the levels 1 to 4. Industry steps in only when it sees a demonstration of the technology at an appropriate level or scale. And so what happens to the gap in between is the question that we seek to answer today, right? Who will take responsibility for this? How can it ever be done, right? How do we overcome this valley of death, as it were, right? And one of the submissions is that, the incubators that are now coming up in academic institutions, they, I believe, have a very special role to play to be able to address this gap. Because when industry is not interested below this, right, you can rest assured that the venture community will also be not interested below this, right? I mean, they will talk. Some of them may, support you here, but most of them will wait till you sort of cross this hump and only then come in to support you. And so that's the challenge that, we are faced with, right? So just another picture where, the sort of milestones are shown. I'm not going to dwell too much on this, right? But this is from the point that, from the lab, the technology is transferred to the entity that is going to take it forward. But, by the time they become successful as a business, right, the sort of requirements are so large that some of them are not able to climb out of this valley. Okay, so as I said, this is particularly acute for hardware products, especially in the health, medical devices, medical technologies, mobility, in all these places, primarily because compliance and certification, compliance with statutory regulations can place a very heavy burden, right? You have to have multiple prototypes. That itself can be a killer, right? You need to find resources to make multiple prototypes. Who is going to provide you the money? And then certification is not inexpensive, right? It costs a significant amount of resources, both in terms of time to get all the paperwork filed and approved and then be ready for the testing, And then the actual trials itself is not cheap, because the people who bring in the volunteers, they have to spend a lot of resources to get them in. Liabilities have to be accounted for and protected against. So this is not an inexpensive process. And so that's very critical for products which are based on hardware, right? And especially ones that are in these spaces. Right. And the problem is that, you know, we may say that, okay, maybe I will delay certification till I get money, but then, you know, investment doesn't come in if it is not certified, or if it comes in very, very hard and, you know, very bad terms for the company or the startup. And so it becomes unattractive. Right. So here is a feel for the kind of numbers that we are talking about, right? So if you see the first stage where you have the concept proven, right? You may look at about, 1%, right? Now, to take it to sort of a stage where you can start market studies and market testing, user testing with it, you need to spend 10x, right? And then, of course, you need to spend, you know, another 9 or 10x times that for the acquisition of the market, etc. But the point is that, you know, people are willing to spend this kind of money, but they will not be interested in, you know, investing the resources that you need here, right? Because this risk is something that daunts them, right? Though they don't realize that, you know, they still have to spend so much to get the product up. And if you look at the final analysis, the amount that they need to spend is within 10% of the total budget, right? But somehow, because visibility of success is much more here and less here, this fact seems to be lost on this. Okay, so let's see what can be done about this. So typically, if you see any innovation ecosystem, it could be an academic department, or it could be an incubator. An incubator is a better example, because it is an academic incubator, especially because one assumes that the entire academic infrastructure is also available to the incubator. There are 4 main things, right? There's knowledge that is being created and that is already there in terms of the resources of people, human resources, faculty, students, and scholars in the system. Finance, of course, is something that is always required. Services, as in infrastructure and prototyping, analysis, simulation, those kind of things, and of course the people who do these things, right? Now the key is that all these 4 have to sort of play together, so that the transition from a concept that works in a lab to something that can be taken to the market can become feasible. And the reason why I have not put finance in blue but the other 3 is because the academic system can only provide the other 3, right? Finance, it can only be a flow through. Unless somebody gives it money, it cannot give money to these efforts, right? And therefore, that's why I've sort of made that distinction, but it is critical. It is critical, right? So that is where, the government funding typically comes in. And this is, a reality that governments need to sort of come to terms with, is that a lot of the, lifting of the load has to be done by the government, right? So if you look at the penetration of solar energy as an example, right? The cost of deployment of this technology, very new technology, has come down very dramatically in 1 decade in Germany, which is why the adoption there has been huge, right? And that is primarily because the government stepped in with very attractive schemes of a buyback of energy produced by these panels that you mount on your residences, and of course regulations and some sticks that they had, right? But nevertheless, they put in dollars or rupees or pounds or euros, to back technology, and that is very key. And in Denmark, you see the same story with wind energy as well, right? But you also see the same thing in a very more indirect way with some of the more successful innovations which you do not associate with public funding, right? The smartphones from Apple, the perception is that this is primarily driven by industry, funded by industry, and so forth, right? But it turns out that all the key technologies that are responsible for the success of this particular product, they were all public funded research, right? Either the defense or the agencies of the government funded these the development of these research, right? And likewise with Google, the original search algorithm that forms the basis of Google was an NSF project. Pharma, right, which claims that they spend so much on this, actually the bulk of that money is actually coming from grants from government agencies, right? And therefore, government still has a very heavy role to play in the transition from what is there in the lab into what is there in the product, right? And our own success story in the IT industry is again, people attribute it to the companies that entered this game, but they ignore the fact that the government had a role to play in underwriting some of the risk by giving tax holidays. Network connectivity was established in specific zones. Import of equipment was allowed by foregoing revenues that usually accrue because of those things. So the finance resources, typically you can trace them back, and especially the critical ones, to the government funding. And that is a key point, that we should not lose sight of, because our own government also is suddenly enamored of private funding. But private funding cannot, do this kind of heavy lifting that is required to create new industries and, new product market spaces. Of course, and this is not to berate the contribution of the entrepreneur or the companies that have been responsible for this success, right? They have a role to play, that this look at inventions that can be innovated upon, and that's also requires a very keen sense of perception of what might play in the market and what cannot play, and what can be translated now, what cannot be translated now, right? And therefore, this is also a key ability that is required in our ecosystem. But the first one is also important, and that's one of the points that I wanted to leave you with. Right? So the contribution or the sort of the risk or the reason why the entrepreneur deserves the rewards is due to the kind of risky calls that they make, which sometimes kill their own product markets, right? When Apple decided to launch the smartphone, right? They were actually going to influence, actually not benignly influence, they were actually going to destroy the markets of these products that are there on the right? All of them. But the reason why Apple's success is very creditable is because they knew that one of their own products will actually be into oblivion, right? The iPod, the music listening device that they had created with great success, right? They knew fully well that this new product is going to, sort of cannibalize in that space, but they nevertheless took that risk and went. And that is the risk that they need to get rewarded for, and that's fair. And that's a call entrepreneurs have to do, and some do it well, some don't do it well, right? So that's what we should appreciate there. Now that we know some of the issues and some of the challenges, right, I want to now spend the rest of the thing on what academia can do, right? And when I say academia, it can be departments, but I'm more biased also towards incubators, right? So what can they do to sort of address the issues that this transition faces, right? So some of the things that we sort of understood from our evaluation. Remember, I had given you the scorecard earlier, 3 out of possible 200, right? We sort of listed these as the reasons, right? One, that we are not exposed to the marketplace, right? We may be in big cities, we may be in small cities, but the moment we are inside the campus, we seem to be sort of, cocooned off from the marketplace. And that has, enormous impact on the kind of decisions we make in product design, product development, and therefore that is a weak link, right? And what we feel can address that thing is what we call immersion, right? And this is something that we have started doing now, is that we force the development team, we force the founders to sort of go to where the product is being used, and we will see more of this. So that's the thing. One of the challenges that we realized also in the difficulties in translation was that hardware products, right? Products that are based on some science or some technology, right? Their design is not trivial. I mean, people sort of think that, oh, I can develop an app in 15 days with 2 people, right? How can this be any more difficult? But the challenges are completely different. and extremely hard in this case. And that is something that must be appreciated. And of course, the key point that we found was that what you create in the lab is a prototype, and what the market needs is a product, right? And that distinction, again, there are huge differences that you need to appreciate in this, right? The last one, and which is something that is more, I would say, personality or a cultural trait, we do not know which, but that collaboration, right? I mean, designers say that it is a collaborative discipline, and so we collaborate. But truly speaking, designers do not collaborate at all, right? There is extreme reluctance on the part of designers they will ask very specific questions about something that they want an answer to, but they may be asking the wrong question. And they don't realize that if they collaborate, then they may be able to get a better solution than when they try to capture the problem in the form of a question, which turns out to be the wrong question. And so that's another issue that we felt that should be addressed, right? So this is the thing that we thought how to solve these things. So the incubator, right, we felt should be doing some of these things, right, which is to provide funding. And of course, they cannot do it on their own, but definitely this gives a reason to raise money from government sources or philanthropic sources for taking a student prototype and move it to a demonstrable product, because that costs money. It is not that I have a working prototype, so it is just a question of making more in numbers. No, right? There is an almost equivalent effort in product engineering that needs to be done to get a product out of this, right? And the problem is that angel investors who are supposed to sort of come into this stage, right, they are also equally risk averse to product companies, because they have not seen successes in product companies, right? They follow successes, where they have seen success in the past, they'll continue to, fund those. So this is one issue that incubators then have to play, right? How do we raise resources to support that transition, so that then with the demonstrable product, the company or the founder can raise funding from the marketplace, right? So one of the things that we decided was that, if a student project is there and it is interesting and passes through some evaluation, then it can be supported for at least 2 years to get this version 1 of the product out at least, right? And also expose them to all the statutory compliances that a product has to do, right? Now, these are very expensive, right? From simple products, it may be about 8 lakhs to about 25 lakhs for something like an oxygen concentrator, right? If you want to go get this certified, right, these companies will give you a quote for about 20-25 lakhs. And if there are some simpler projects, they may ask you for 8 lakhs. Now, why they ask that, we do not know, but we have been working with the government and raising this point in the government that India must have its own certifying kind of body, where we don't, have this kind of huge cost overheads that goes on to the product company. And the last thing, of course, is something that we need to teach the founders from the beginning, is to bring in the business perspective, right? Where is the money going into the product, and where is the money going to come for this purpose, right? Because both are not bottomless, right? I mean, we don't have an infinite source of money, nor can we keep spending infinite amounts of money on the product development, right? There has to be a plan. And so they need to have this, what we call excelpertise. I mean, you typically have to make an Excel sheet or a spreadsheet, which keeps getting, updated as things change. And we need to expose the students for that, right? So we ran this kind of a 2-year finishing school. We, of course, didn't call it a finishing school. We called these fellows entrepreneurs in residence, right? So that the objective was clear, that we want them to become entrepreneurs once they leave this program, right? So that's something that we were doing. And this scorecard looked much better, right, for us. And therefore, I'm happy to share this with you, because we picked about 15 teams in this program. This was over a period of about 5 years and in 3 cohorts, right? So first year, some companies, second year and third year. And then they ran for 2 years and some for 3 years at a stretch, right? So all the red ones actually have now become companies, right? And the blue ones, they are right now talking to people. So we will wait and see what happens. And I would say that almost all the red ones are right now cash flow positive, which means that they may not be making profits. Actually, one of them is where is that? the Mediplay systems, the critical care training simulator. They are making profits. And Sickle, of course, this is a company that I said started with cotton harvesting and went to Apple. Now they do other agricultural products. They become a company. And so they are doing quite well. But all the red companies are meeting their ends through their own resources. So that's something that is very good, that we are very happy about. So one of the things that, as I said, we've learned both this exercise and in the previous exercise is that a lot of times when we do design, we think that, we should have a low cost product. And therefore, typically students will say this in their presentations, that an imported product costs 1.45 lakhs. I have done it for 20,000 rupees, right? But the point is that the bill of materials at the stage that you are in, right, is not where the game ends, right? There is a product to be created out of that. Typically, students will argue that, I'll buy in volumes, therefore I will save. But then there are other costs as well, right? There is a supply chain, and you have to do packaging, you have to do delivery, you have to do support. All those costs have to be added, right? So a typical metric is not that your cost will come down when you buy in volumes, but rather your prototype cost is X, your actual product cost you must think is 4X, right? When I say product cost, as it lands in the hand of the user, right? Now you can take your margin out of that, but the rest of it is actual cost, right? That you have to pay for shipping the product, packaging the product, training, sales. All of this has to be factored in, right? And therefore, that's something that we need to drill down in their mind, that affordable bill of materials is not the end of the story. It's a good point, great, we take it, but there is more beyond. And same way, prototyping is not manufacturing, right? You have to worry about packaging, you have to worry about serviceability. All of these things have to be worried about. And of course, as I said, you may not like the company that is doing the certification, but you have to get certified. If you want to sell a product, you must plan on being certified, right? And therefore, that has its own implications. So here is one product that I just wanted to share. This is done by a colleague of mine, right? And I share this only because that this is possible even in India. That's the point I just wanted to leave the audience with, right? This is a radial arm prosthesis, as you can see, right? And I'll just probably turn the video on. I hope I can get it to work. Yeah, while I'm speaking, right? So the nice thing about this arm is that it is controlled by the user, right? But the effort that is expended by the user is only of clenching and unclenching the remnant of the muscle. That's it, right? That's all that will drive the whole process. And he's able to, as you can see, lift objects of various geometries and various material textures, right? And you can see some pictures in the bottom as well. So all of this is possible, right? Now, and this is made completely in this country, right? This is a prototype and then a product that in multiple copies have been made. Clinical trials were done with Mobility India throughout the country, right? And this has been done. But the interesting point that I wanted to say to you was that this was done through a grant from an Indo-UK funding agency. And, so you can see that he's able to shake hands. So multiple configurations and grips are possible, right? Now, the point I wanted to make was that this was done in collaboration. There was a project with Oxford where the intent was that this design would be made by them and tested there. And we would make it here and test it here and then sort of learn about clinical trials and things across both the countries. But when we took this prototype to UK, right, they found that they could not produce a product of this quality with the budget that they had got. And they already had about 9x the amount that we had got, right? Even if you say that the pound is 100x rupee, right? Their budget was 10 times what we had. And they could not make this finish there, with the budget they had, right? So the point is that it is possible and it can be done, right? It does take resources, but you will still be competitive in the world market and definitely in India also if you make a good product, right? So it is not that you need to go to China or you need to go somewhere else, right? It can be done here. And so that's the first point. The second point that I want to make is that it can also be done in time, right? Because one of the things that typically you will see about Indian manufacturing is that they will say, we take much more time. The Chinese vendor will respond in 3 weeks, we will take 6 weeks and so forth. There are reasons for some of those things to happen. I'm not going to dwell on that here, so because it is not entirely untrue. But it is also not that we cannot do it in time. Here is an example of a product, right? You see the CAD model rendering of this product. This is basically a product for craftsperson to stitch the sole to the shoes, to the upper sole. Okay, for people who make these shoes, this Rajasthani style of jutis that they call it. That's what this device was meant for. And of course, the innovation in the design is that the effort of the person in stitching, because the sole is this thick, right? And you have to push a needle through that, right, of leather. And therefore, it takes enormous effort on the part of the craftsperson to push it through, right? And so the idea was to only help in that step. Everything else is still done by hand. But that particular step of stitching the sole to the inner was done by this machine. And this whole thing, from the initial problem statement to this design to this prototype that you see here was done in 15 weeks. Right, by 2 students. Right? So clearly, the lesson that we take from this is that it is possible. It is not that we need to take infinite time to do a quality product. We can do quality products, and we can also do it in time. Right? And it is just that of course, we must have resources, but also the will to sort of say that it will be done. Right, and the prototype. And here, this happens because the students cannot get the top grade in the class if there is no working prototype. And so that is a big enough incentive for them to actually produce a good prototype. So the other thing that we tried, and this is something that we had shared in one of the meetings earlier, but I just thought I'll mention this here again, is to work with industries, especially the small and medium industries, right? The idea was that the students will identify a product that an industry is interested in and develop this product over 2 semesters of courses with some internship over a summer in between the 2 courses, right? So the idea is that the product concept is done with the business context awareness, because that comes from the SME partner who is also part of the team, right? They sit through all the entire design exercise that is done over the year, right? And what the students do is that they work with the SME and come up with a concept design in the first semester, and then sort of go do their internship in the company in summer, where they build a prototype using the facilities available at the company. Right, with the feedback and changes and comments of the company incorporated into that concept, and then they bring that new revised design or concept back to the campus, and in another course they will actually build a working prototype, which is done through the formal processes of simulation, testing, analysis, and everything else. Right. So the idea is that at the end of a year, this SME has not only got a design for a product, but also the entire CAD model, working drawings, manufactured, and the working prototype, right? And so that the company can then run with it, right? So the process is listed here. The main point here that I want to highlight is this last one, that the product strategy, right? Where you do your market study and market data, right? We keep emphasizing that market is not your colleague next door. Typically, students will just go ask their colleagues or the friend of their colleague and say that 10 people like it, so I'm going to do this, right? You have to be honest and go into the marketplace and talk to the actual users, right? We cannot shy away from that. And the second point that we learned from this is that there is a cycle of multiple prototypes, even to get the design right, and therefore it is important. So we do 3 cycles almost. First, at the end of the first semester, where the concept is prototype. Second, at the end of the internship, where actually a prototype is built in the facilities of the SME. And last is the final prototype that we build, which improves upon all the others, and a formal prototype at TRL 4 or 5 is ready. So as you can see here, some examples from this effort. I'll just walk you through some of these. The first 2 are for a company. We built a warehouse robot, right? And so the idea being that if the spacing between the racks and all is too small, right? So you need to have a very interesting kinematic design for the robot so that it takes a very small footprint, but it is able to access all the shelves, it is able to grab and put it on the tray, right? The next two, which is this particular, sorry, I shouldn't have clicked on it. Yeah, this one here and the one that I have highlighted in the red. This is a very interesting product because this is the requirement came from a company that used to make white label manufacturing, that used to do white label manufacturing for big multinational companies for solid state relays. So they will manufacture it, but their name will not go on the product. Those guys will put their stamp on it and sell it. And so they came to us and said, we know this technology, so give us a product that we can make. And so the students actually came up with the idea of a smart controller, right, based on these solid state relays, right? And the advantage was that it became a platform. Instead of one product, it became a platform product. So that can be used in multiple places. So here, the example you see is of a polyhouse, right? So this smart controller can be used to control all the actuating elements inside a polyhouse, you know, the moisture, the light, the fertigation, the this thing, all of that is controlled by this one smart box, which has these relays from the company's products itself. But the same kind of controller can also be used in a food processing industry, say for making cookies, or, you know, in a manufacturing industry for electroplating, right? And so that became a very nice thing for the company, right? And now they have actually set up a new division to launch these products, and the first of them is getting done. And there are other multiple products like that in this particular case. The statistics here also show that, you know, the filtration that happens, right? So we start with about 24 prototypes, right? Which means 24 projects. But ultimately, you know, only a few of them make it to the next level of a product. And so that is something that, you know, we have to factor in as an incubator or as an academic department. And the only way that we can increase the numbers, therefore, is to do more of, you know, these, so that the percentage is maintained. So two other points, again, you know, from a training or an education perspective, is this notion of the context in which design happens, right? So our view, and this is from a colleague, Professor Govindaraju, right, that design is defined as a process that is supposed to come up with a solution that is compatible with the design environment. Now, what is meant by design environment is basically the world in which the design is going to work, right? Both the design is made and the design is going to work. And the solution is found within a design space, right? Because the design space is limited by the capabilities of the designer and the manufacturing person and everybody else, right? So these are the two operating things that, limit or extend the capabilities of the designer. The constraints in the design environment that must be respected, right? And the available design space, which can be enhanced, right? So design education, or any education for that matter for innovators, must enhance the design space that they have. Their ability to come up with solutions. And this is very much like the solution space that we talk of in math and optimization, right? If you don't have a large number of solutions to pick from, right, you will not have a good solution, right? An optimal solution. So we need to enhance that, and our understanding of the design environment must become better and better. So let's see what we mean by that, right? So design environment is something that the designer cannot control, but it is going to be where the design is going to be used, right? So this can be a physical environment. Now you can design a very fancy product that needs 230 volts at, you know, perfect sinusoidal frequency, and this is going to work in some place in Chamarajanagar where there is no grid power, right? Clearly, then you have not respected the constraints of your environment, right? A very classic example of this, you know, is when India liberalized and a whole bunch of big foreign players came into the country with their designs for these light commercial vehicles, right? Swaraj tied up with Mazda, Toyota tied up with somebody else, Eicher tied up with Mitsubishi. So multiple big players came, right? 4 years later, when the dust settled, there was only one player left standing with the dominant share of the market, and that was Tata Motors, right? Then called Telco. Primarily because they understood the environment in India. They understood that the roads are not perfect. It will always keep seeing multiple shocks. More importantly, Indian users do not respect the axle load limit, right? You can keep saying, I'm giving you a 2-ton truck, but rest assured that they will load it with 4 tons and take it, right? And therefore, Tata Motors understood that, right? They understood that, it has to be over-designed, and it has to be, taking into account this fact that nobody is going to respect this. So with the result that while all the others ended up having failures on the road, Tata Motors laughed all the way to the bank, right? And so that is very important. Likewise, you must understand what can be done in this country and what cannot be done in this country. People don't invest in maintenance in this country. So you cannot say that my product will work well if you put 2 drops of this oil every 3 hours, right? And there is no way that this is going to happen in this country. So you can keep saying that my design is great, you guys did not use it properly. But the point is that you have not understood the design environment. Likewise, this is another, classic example of the design environment, which is these ticket vending machines, platform ticket vending machines that you keep routinely seeing in all our our train stations, right? So they will have this thing, and you say put coins and it will come. And within 1 day, it will not work, right? The reason why it does not work is 2 things, right? One is that, while they design the machine, they forget that the coins are designed by the Reserve Bank of India, right? And the Reserve Bank of India goes to the cheapest place where they can get these coins, so that the coins, the same value coin will have 3 different shapes. You cannot design an automatic vending machine when the shape of your coins are going to change on a daily basis, right? So that is a straight shot, failure thing. Of course, there is this Indian jugaad here, right? You will find that the second day, there'll be a kid standing next to it who will have the right size of coins. He'll charge you 50 paise more, and he'll put those coins and get you the ticket. Right? And that is our ingenuity, but definitely it is not a credit to our designers, right? Because they fail to understand that, our environment is such. How do we improve our understanding? So one is, of course, that we must pick up the products that work and understand why they work, right? And of course, second is ask a lot of questions, right? Like I said, one of the mistakes we make is that we don't share information with others. We ask the question that we think we need to ask, but actually the question that we need to ask may be something else. And that can only happen if we start discussing with somebody, because they will ask some questions, we'll answer them, some new questions will come and you answer. Whereas if you say, no, you just tell me, how do I put this into this? Now, why do you want to put into that? You won't say. Maybe I can tell you a way that you don't even have to put this into that, right? But that does not happen, and that's a problem. Right? And quite often, reflection, which is a very critical ingredient of almost all disciplines, right, goes missing in design. People think that design is meant to be instinctive. It is meant to be that aha moment, but it is not, right? There is a lot of structured thought that goes into coming up with a good design. And therefore, this reflective thinking has to be introduced. And lastly, of course, is notion of immersion, right? A lot of people say voice of the customer. And again, the same mistake. If you ask the customer a question, he will say what he wants to say, right? But it is not the real problem, right? And Henry Ford's quote is actually brilliant, from that perspective. That when he says that, if I had asked my customer what he wants, he would say, I want a faster horse car. But the articulation is not that. The problem that is that you want to go from place A to place B in the quickest possible time, right? And that's the problem Henry Ford solved. So that's why you should walk in their shoes. Rather than ask them the question, you try and, immerse yourself in their use environment. And that will give you an insight which will be much more than what the designer himself or herself the user can himself or herself tell you. Okay. Now, the other part, designs, is I was planning for an hour, so I'll stop in about 10 minutes. So that should be okay, right? Yeah. Okay. So
please go ahead.
Okay, thanks. Yeah, sure. So the design space on the other side is basically, like I said, like your solution space in math, right? This is the space of feasible solutions. And this is constrained by the knowledge you have and the capability that is there in the country, right? So a classic example is our light combat aircraft, which was designed in the late 70s, early 80s, right? They just went ahead and said it will be an all-composite aircraft. Right? But when they did that decision, they made that decision, India had zero capability in composites. Right? We had no capability in composites. So therefore, the design was actually incompatible with the design environment. Right? And this probably was one reason why the project was delayed, because they had to build the design space first and then execute their design. Right? And this is always limited by The knowledge and the technology that we have access to, right? So how do we enhance that? Right? How do we improve our design space? The way we improve our design space is to practice design, right? You do projects, what we call technology demonstrators. And that is the reason why the LCA should not be evaluated the same way the other aircraft design projects are done in other countries. Their goal is only one: make the aircraft. Here, it's a technology demonstrator, which means that it has to work to increase all the accessories, the design space around that, right? Composite was one, fly-by-wire was the other. All of these India had no expertise in, right? They all are now in the country because of this project, right? So delays will happen because it is not just a design project, it is also creating capability in that space. And of course, research and continuous learning, nothing can beat that, right? So the good thing about doing design practice is that it tells you where the gaps are, and then you go after those gaps, and then you are ready for the next level of design, and then that's how it goes, right? So this is again an important thing, that we must enhance our design space. Now, here is one other weakness that academic institutions have to learn to fix, and the way our institutions are set up, and this becomes a big limitation, right? Which is that we have no nice way of absorbing people who do not have the standard university qualifications that are expected, but who are very capable and very critical for this transition from the TRL4 to the TRL7. We call them system integrators, right? These are people who have experience in product engineering, which is not the same as product design, not the same as prototype design, right? They understand, what it takes to make a product out of a given technology, right? Vibration isolation, noise reduction, clamping, holding things in place, right? Packaging, right? These are all things that students will not know upfront. So you need somebody who has experience in all of these things, right? But unfortunately, in the university faculty system, we don't have a way to bring them in. We can either bring them in as a mechanic, which is sort of an infra dig for these people, because they are, product engineers as such. And so that's a big problem, right? Of course, in IISc, we had this scientific officer cadre, but, that sort of, again, got distorted. The country as a whole had the CSIR system. And the idea was then, I think, that academia, the academic institutions will do the research, CSIR will do the translation, and then industry will take the translated products. But then what happened was the CSIR started doing research by itself. People in CSIR started getting evaluated by the number of papers they published, and end of story, right? And therefore, it is very important, right, that academic institutions now become more accommodating to these non-traditional backgrounds. If you see most Western universities, right, in the most successful research groups, you will always find these people whom we dismiss as mechanics or, technical officers, but they play a key role. They sit in all the research meetings, they participate in all the discussions, and they contribute to the product development exercise. And that is key, right? And that collaboration is important mainly because, and this is an example from architecture and construction, right? That architects always think that, they are the prime movers and, they're responsible for everything, right? But that was the first drawing that was made by, the person who conceived of this, right? But without Gustav Eiffel's contributions in terms of the intermediate stages being developed and, stability into the structure and all of that, right? You would not have had this enduring structure today, right? And therefore, just like architects, those days used to collaborate with civil engineers, right? And a lot of people believe that the decay in architecture today is primarily because they stopped talking to architects. The Sydney Opera House again is a classic example, right? Where the architect and the engineer talked from day one, right? And so the same thing needs to happen here. That you need to have the product engineer with you right from the beginning, right? Because they can improve the product and also make sure that it is realizable. And that is again a key requirement. Okay, so I want to close by saying that, this structured approach to this whole design that I have tried to outline, can help you mitigate the value of death. And some of the key things that we want to emphasize, and which we believe in our own experience was successful, is to expose students the difficulty is in moving further along the TRL. As I said, this can be post their graduation. This cannot be tied to their graduation requirements, but those interested and those that you feel are good products to be pursued can be doing this. And of course, this whole thing that there is an iteration in this process, right? You have to prototype, that's the visualization part, test, and then again, do this. Right? And the diversity in the star there and the next bullet of collaboration is the same thing, that you need multiple players into this thing, right? You cannot have just the designer taking that I know everything, I know this is my baby, I will do it. No, right? You need the engineers, you need the technicians, and you need the business guys, right? Because at the end of the day, technical feasibility is just one pin in the one peg or one leg of this, right? There has to be an understanding of the requirement from the market. I'm not saying that it is answer to a question, but understanding of the need and of course the viability from a business perspective. All three are important here. And therefore, that must be sort of kept in mind. Right? And that's pretty much everything that I wanted to say today. I thank you for your patient listening, and I'll be happy to answer questions if I can. Yeah, thank you.
Thank you very much, Professor Gurumurthy. One thing you have made very clear through your presentation is that the basis of moving forward would be, of course, collaboration, coordination, as well as, of course, cooperation that must exist in whatever we are trying to do, which therefore, with your advice in the past, became the mantra for the DST Tech at our place. We put these three C's together in order to bring everyone together, from the area for which we have been created here. And we also realized that it cannot be that an idea just survives all through as an idea. It has to move from ideation to translation, of course, and then finally, of course, wherever it reaches. And between ideation and translation, the research component that comes in, the academic institutions that have to work towards taking that idea to a tangible, goal, probably again became the basis for which we are now trying to bring many institutions together. When you do visit us, you will see these signboards at the entrance of our DST Tech that we have set up, sir. Now, I think everyone would agree that having the chief executive heading the Society for Innovation and Development at the Indian Institute of Science was probably the best decision for today's Technology Day talk. I'm sure, like me, everybody feels illuminated. Most of us in academic institutions are laboratory researchers, and we do not really see anything beyond the little bit that we've done or converted it into a publication. And you rightly said, no one reads. Many times it's we alone who read, and rightfully, the government has said self-citation does not get you any points. So no second person is also reading to cite it, and therefore you don't really get to be recognized for what you've done, even for anyone to take it forward. Sir, I would think that this illuminating lecture from an illustrious scientist has been an eye-opener for all of us, and you have shown us how it's important to keep eyes and ears open, but more important is to have an open mind in whatever we want to take forward. I would now, since this is, of course, a YouTube presentation, I have to now ask my colleagues to see if there are questions, and if they would like to post it in the chat box is okay. Even if there are no questions, I'm sure everyone now has 1,000 questions, and everyone will now believe that what they thought was probably the best discovery has 1,000 miles to go before it can see light of the day to become a technology. And you have made that amply clear in what you said. So if there are questions from any participants, sir would like to take it. Otherwise, you just put it in the chat box. We will forward it to him. Karun, would you like to start with any questions to Professor Gurumurthy? Karun?
Yeah, I must thank Professor Gurumurthy for this excellent talk. And you took us through the whole process of, say, from research to prototype, and then how the prototype can be taken to the product level, and what all it takes in the journey, and how you support students during this process. And you also emphasized on the need for meeting the regulatory requirements. Now, in Indian Institute of Science, all this support, is it given through the Society for Innovation and Development, or how does this work? And
yes, so yeah, go ahead. Sorry, please complete. Yeah.
Yeah. And when the students are in this process, are they registered as startups, or how does this happen?
So the support from the Society for Innovation and Development (SID) is provided to the startups that are incubated here, or even elsewhere, right? If they come, we try wherever we can. We will extend this support to them as well, right? The duration, the support on the entrepreneurship and residence type programs, it is run on both sides. That is, SID also runs it, and whenever we get some funding on the other side, the academic side, there also we run this program. But now we are formally running it from SID alone, where we have a number of such founders, or potential founders, I would say, who are working on this. For the certification and other things, right now, what we do is on a case-by-case basis, we try to connect them with the appropriate expert, or a consultant, and then, work with them to see if we can mitigate the costs somehow and make it manageable, right? But that is something where we are also trying to work with the government to see if we can arrive at a somewhat better solution for that particular problem. The biggest thing about the certification you will notice is the bookkeeping that happens during the process of design. So that is something that, since we have learned it now, we are now trying to see if we can hire a person, eventually a team, which can then work with these startups to sort of coach them on at least the paper management of the process, so that even if the actual certification cost is high, that it cannot take so much time, because they would be already ready with all the paperwork. So that is something that we are trying to do. But for now, we just connect them to the right people and help them like that. Yes.
Thank you very much. And also, do you have any short-term courses on this design? Of course, for example, particularly for biologists, I think there are something new. So, are there some courses that you can advise for biologists to go through this process?
Yeah. So there are two groups in our design department. They have a medtech focus, that is medtech devices focus, right? And so that group can actually put together a workshop if you are interested, right? Starting from some basic concepts to certification processes, clinical testing processes, and all of that, and do a workshop like that. So that is one thing. And there is also this biological systems and science and engineering group on the campus. I don't know if they run any large, such workshop-like programs, but if there is a request, I think we can work with them to get a workshop organized for interested people.
Okay, thank you. I think that will be very useful for us.
Sure.
So we will contact you.
Sure, please do. Yeah, we can definitely work on that.
Can I have you answer a question? It may be a silly question, but
no issues, ma'am. Please, yeah.
I think now there have been so many words which actually I could say are jargon. Okay, we see the word startup, we see the word incubation, we also see the word entrepreneurship, which is of course an adjective I see. But when there is a technology and we are like bridled horses who can only look at that technology as something that seems like having the possibility of becoming a huge industry with a lot of profits for people who are working with them. But so between that little bit of research and the little bit of, say, some testing that is done, showing the potential of it to become an industry, there's such a big gap. We know government has a lot of programs and many institutions are recognized to help startups or to let them go to the next stage by giving them funding. But there is a lot of gap in being able to prepare an ideal project to present there. The technology is there. Now, would your institution be able to help by seeing the possibility of making that go to the next level? Because we can see that there is promise, but we see more difficulties in it. It is not really the money, sir. I think it is beyond the question of finance.
Sure. So the choice of, just like even in science, right? The question or the problem that you want to work on itself is a very key decision that you have to make right in the beginning, right? And so the same thing is probably what you are saying with respect to the portfolio of ideas or know-how that may already be present. Actually, the same challenge is there. Most everybody will face the same challenge that you are facing right now. There are ways to solve this. I mean, if you say, can we put together sort of a people who can give you advice from their experience and their expertise? Answer is yes, definitely. We have access to people here being in Bangalore and also having our alumni, as a strength, right? We can definitely, tap them and have them look at maybe an abstract or a synopsis of the know-how and say that, these are the possibilities, A, B, C, D, and we think, go, no go kind of, input can also be given. Certainly, yes, I think. I just want to tell you about a very similar thing that is done in this Israeli university. The program is called Remote. And I think the university is Tel Aviv, if I'm not mistaken, right? So what they do is that they have a group. I think that group is called Remote, if I'm not wrong. They will look at the portfolio of patents held by the university, right? And they will then see who are the people who might be able to take a technology they think is interesting to market, right? And then they will fund that team. Now, the team can include the faculty who did the original development or may not. It's not a mandatory thing. It's not a mandatory thing. And that decision of whether it should be taken up for further thing is purely based on the business stroke commercial kind of considerations only, right? So they have a advisory group actually which does this, and they have a pot of money, significant amount of money. But they see it purely as investors, right? The only difference being that they are not necessarily creating a company. Their idea is that we will develop it further so that it becomes attractive for either a startup to run with it, or we can license it to a company and be done with it, right? So definitely in the short run, we can see if we can put together a team of people who can help you, and you can have a conversation with them and get a feel for it. Right, but I would probably urge you to consider this model and see if you can set up something like this with your own alumni and people, because that is a more enduring solution for you, right? And of course, it will always come down to money, right? Because the faculty will say, "Oh, if I have to do this, I need so much money," right? But at least you will know that there is a jewel here, and something can be done with it, which is probably what your intent is right now. Right, to know what the jewels are that you want to market. So I think that's a good exercise, and initially, definitely, we can provide you people who you can talk to and co-opt them and get feedback. Definitely can be done. Yes.
Thank you. Yeah. Can we separate patent from technology? Like what I'm saying is, patent is yes to hold rights over whatever you have developed. Okay, I'm speaking for many others also who are involved with us. Now, I came across this concept because Dr. Vishal Rao in Bangalore, who worked on that vocal prosthesis, he speaks about the copyleft. Okay.
Yeah.
Now,
Yes.
you've heard about that. Now, in such an eventuality, of course, patent takes a lot of time. All that apart, if you really want to think that it's such an important one that you alone want to hold the rights to it, then it's another issue. But if it is directly going to a technology state, is that a good idea for young people to pursue?
So here's the thing, right? I mean, I think we must separate this notion of ownership, right, from this notion of exploitation. Okay, because whether it is patented or not, right, if you have created a know-how, right, it is your know-how.
Yes.
And people who are exploiting it must acknowledge that, right? That's point one. What a patent does is that it gives an assurance to that person that this actually does belong to only this person. Nobody can question me in the future if I choose to exploit this, right? That is one part of it. And I think that is where it is important that universities, whether or not there is a patent, if there is a know-how that is going from a faculty or a lab or a group to somebody outside, it must be recorded.
Yes.
Right? Now, exploitation, fine, we can discuss that separately. Right? There are various models to that. You can say, right, if you are making money, then you should contribute some royalty to us, right? Or you say, I don't care as long as you don't, make profits out of this. Right? So that you can decide on the model based on what we can execute, what we can do, etc. But that acknowledgement that this has come out of this lab, right? It works both ways. For you, it is a recognition and gives you credibility for further fundraising for your own research, etc. And for the other person, it gives comfort that, oh, there is a document that says that this is from this lab, so nobody else can come and question me tomorrow. Right? And that is important, right? Because that person should know that Nitte or IISc is going to stand behind this. Yes, that we did this, right? And therefore, I'm giving it to this person, and he can exploit it, and nobody else can. So that should not be discounted. That should be, we should pursue that part. The exploitation, revenues, etc. That okay, fine. We can always come up with some acceptable model and live it. Yeah.
Thank you. Now there is a question from one of the participants. From a researcher or a student perspective, when you have developed a technology or a device, is it better to be a startup, an individual entrepreneur, or transfer the technology to an already established company?
So, I mean, again, it depends on your own goals and plans for your own future, right? The startup and the company are both in many ways the same thing, right? Except that in one case, you believe that you can do the best justice to it, and therefore, your passion can drive it to better heights than somebody else, and therefore you do it yourself. And of course, the rewards also should come mostly to you. So that's the startup. And if you feel that, look, I'm not interested in the nitty-gritties of the business side, raising money, I'm not interested. I have developed a technology. That was what I wanted to achieve. Now I want to go on to look at other problems. Forget about this. I'll give it to somebody. So that's how you should make that decision. The individual versus entrepreneur versus startup is meaningless, because as an entrepreneur, you have to have a startup, because most organizations would not like to deal with an individual, even government, right? Except now India, because of the nascency of our environment and ecosystem, they are allowing it. But going forward, very soon you will see that they will say you must incorporate yourself, because the legal framework demands that, right? It gives comfort to both sides that they are dealing with companies which are governed by some rules and regulations. So that's a technical question, and I think the answer to that is very clear, that you have to become a startup. But between a startup and a company, it depends on where your interest is, right? Are you going to spend all your time thinking about how to make this successful? Or are you more fascinated by the fact that how can I make this product better? How can I solve that problem or this problem? If it is the latter, you better license the technology and move on to your interest. But if you think you can be obsessed about the success of this product in the marketplace, then you should form the startup.
Thank you. there is another question. Could you please throw light on India's position in the world, the technology development concern?
I don't know, actually, to be honest. There are statistics in terms of startups. We are number 2 or number 3 now, and all of those things. But those things, I do not believe mean anything, right? I believe that we have a lot of strengths, right? We have a lot of capabilities, and we have a good history behind us as well, right? But are we, where we should be in terms of that impact? I think the answer is no, right? I mean, numbers can say anything. You can find a statistical survey that makes you look the best. You can find a survey that makes you look the worst. So I will not go by that. But we know in our hearts where we are, right? There are several things for which we should have our own solutions. We don't have it, right? And therefore, there is a lot of distance to be covered. But that said, right, we take encouragement from the fact that both Indian companies now are fulfilling, global requirements, right? Vaccines, you have seen already. It's a very remarkable story for us, and scooters, we are competing with the best in Europe and Africa, and our companies are winning, right? Software, of course, there is not so much software products, but software services. But now in a class of software products, again, we are becoming good. So I think I would say that we are still work in progress. If you say, are we in the top 3 or 5? I don't think in sum and substance we are not. I think there's still quite a bit that we need to do, but we can do it. And I'm sure we will get there sooner than later.
I have a personal question.
Yeah.
Now, I have heard that only about 10 to 15% of the startups actually make it to the next level. Is this a fact? And if the others do not, what could be the main reasons? Because you have spoken a lot on market surveys and every other aspect to really make the startup become a full-fledged, successful, company or whatever. What do you feel? Why do startups?
I think the 10% is right. What you say is right. I think roughly you can take a little bit here and there, but on an average, it will come out to be that number only, that 10% of the startups succeed.
But why is so, sir?
Right? Why is that? Several things, right? One, most certainly is that the product is not at the right place at the right time. I would not say it's a bad product, but it is not at the right time and the right place. So that certainly is an issue. And quite often what happens is that when technology people or people who have built the product also try to build the company around that product, right? We fail to acknowledge that technology or the product itself is a small percentage of the overall game, right? Google, right? They built this search engine. That was their product. But are they making money off their product? The answer is no, right? They make actually money from people clicking on the mouse on some advertisement that is sitting on the side of their product, right? That's the fact. Now, if your ego says, no, I don't want to do all that, my product should make money, you will be like the other search engines that are no longer there in the market, right? They all have died because they thought that they'll make money off the search engine, right? So I think success as a technology is one thing. Success as a company, you have to have these decisions. You must be willing to make these decisions. They call them pivoting, right? You have to do this all the time, because you have to chase money after a certain point in time. And in chasing money, your technology has a very small role to play, right? Electric vehicles, right? When they first came, right? The place where they were commercially successful were in golf carts, right? Now, if you take the view, no, I'm not going to cater to the rich, and it's a lifestyle product, I can't do that, then you will die as a company, right? Whereas you sell to them and then, establish yourself and then go after the other market, you're a successful business, right? A lot of entrepreneurs probably don't think like that. Right? Then, of course, the last thing could be personal stroke, market reasons, right? You start a company and 2 years later, there's a big recession, right? When big companies cannot fight recession, small companies most certainly cannot, and you just die, right? So I think there's a multitude of reasons why these things happen. And I think what we should be very clear about is that quite often, most of it has nothing to do with technology. It has to do with the flexibility in the mind of the entrepreneur, right? Because, and the answer to the previous question, maybe I should have said this also, that I think you should be obsessed about the success in the marketplace rather than your technology. If you're obsessed with technology, then startup is not the thing for you. You should be obsessed with success in marketplace. Then you should become an entrepreneur.
Thank you. Thank you.
Yeah.
Now, in the context of, you mentioned about vaccine, this COVID time saw a lot of things happening in India. And we proved also to the world that we are second to none in what we want to do in this field. Now, whether we take up medical devices or vaccine development or diagnostics or whatever, sir, there is always some component that needs to be imported. Now, are we self-sufficient in saying we can move forward without those imports by first having, indigenous products for indigenous use? Because there may be a small component of that needs to come from somewhere, and your dependency on that increases. So would it not be good if, whether they are entrepreneurs or companies in India, jumping into also that kind of manufacture of quality product, I would say. Sometimes it's for this quality that we are also running to many imported materials. Even today, I would hesitate to buy maybe an indigenous centrifuge of the quality of what I would get from Germany or from the US or from Japan. I'm not saying I'm very patriotic, but when I have tried to satisfy myself by buying an indigenous product, I have always found that the quality has suffered, whatever be the reasons, the components, or what is your, I'm sure you will be very fair in what you have to say for this.
So, yeah, and again, this is a difficult issue, right? Because on the one hand, we said collaboration, right? So
yes.
You collaborate. Now, just because there is a national geography that comes in between, the kind of geography of the country that comes in between, do you stop collaborating, right? That's the question. And especially if the collaboration is beneficial, like you said in this instance, that you do get better performance, right? So do you do that? So that's always a tricky question, and you will find that, with industry also, this problem is there, that they will be all for banning imports in their product. But for the components that go into their product, they will say you should allow imports. Right? So this is the same thing that is happening here, right? And the answer to that, I believe, is that if it is a collaboration on equal footing, right, that you are not, the other person is coming in as a partner, right, where they also have some skin in the game and they have stakes, so that, when there is a crisis or some problem, they do not just walk away from you, right? Then maybe it is not a bad idea to join hands and do things together, right? Because it saves you time, you get to the market faster, right? So I think that's a good idea. But if there is any concern on these fronts, where the other person is only seeing you as another sale, right? And if he gets a better price somewhere else, he's going to dump you and go to the other person. Then some kind of tactical collaboration must start, right? The problem that you mentioned could be overcome if both of us decide to work together to see how I can improve my performance to meet your thing. After all, that other product also became like that because there was one first lead customer who worked with them to improve the product, gave them feedback, and then they went back and fixed it, and then you gave another feedback and they improved, and right. This is a very standard requirement in most, complex products. The lead customer plays a very important role. That person may get a discount, but in return, that person works with you to provide feedback, identify weaknesses, suggest improvements, and all of that. Right? Now, that is a slightly long drawn process because there is an investment of time from both sides, right? You have to spend time because in explaining things and working with them, and they have to respond. Otherwise, you will lose interest in them. You are just giving advice and they are not listening to you, then it doesn't make sense, right? But I think that long run, that is not a bad idea to have, right? That where the lead customers, spend a little more effort and time with the vendors and improve the thing. And the vendors should not forget that, and they should treat them, preferentially over a longer period of time. That's how this relationship sort of grows, right? We always used to say that Indian products in the past used to suffer because we were not very close to our customers, right? I mean, our customers were all outside the country. We were not building any good product, complex products for people here in our country. Now the situation has changed, right? And therefore, hopefully, if we both decide to work with each other, then, you know, good things can happen. But it takes effort. It takes effort, right? And if you are in a critical mission, then maybe the choice is, okay, I need to find a way to work elsewhere. And again, this is where the other bodies, you know, also have to come in and play a role, right? Because we may not be able to see some of the strategic issues, right? It's the government that must say then that, yeah, oh no, this is a strategic area, you should work. And they should also underwrite some of that effort, right? Because both sides are making effort now, right? As an academia, I cannot say that guy is going to make the money, why should I help him, right? Then it becomes worth my while if the government says, okay, I will give you some funding if you can work with that person to improve that product. So there is an effort required. And I do believe that we cannot do all products ourselves. So we must have strategic partners outside the geographic borders as well, right? But that's a decision. You know, I mean, it can go wrong, you know, sometimes. But I'm sure we have resilience to overcome that. But it's a good idea to build partners, you know, which is built on sound business relationships, and they'll sustain, right? I mean, IBM, despite all the Pokhran second, you know, so much bans were done, IBM was still selling machines to ISRO, right? They found a way to sell it because they need the business, right? And ISRO was the only one that can give them that kind of business. So if we are in a situation like that, then it makes sense to collaborate, you know, to have foreign vendors. But if you do not have that kind of clout, then it is a better idea to sort of, you know, develop your own vendor base, support, you know, supplier base. And more, yeah.
Well, necessity became, you know, during adversity,
yes,
such as Corona, it became necessary for us to become very, very independent.
Yes, definitely. Yes.
And therefore, if the engineering sector, particularly in our country, when I say engineering, I'm not talking only about software at all, sir.
Yeah.
I'm talking about our mechanical and all other engineering sector.
Yeah.
If they actually have to make very high quality products, which would probably be there in India, if imports are banned, because quality is the one that is going to speak in the long run, you know, and make themselves competitive like the best in the world. I think we can.
Right. I mean,
I'm not saying we should ban imports, but to a large extent, so much we depend on imports for everything because we
must be
want
rationalized. Yeah, I agree.
So if the diaspora here makes really, you know, good quality stuff, I'm sure we will all turn, not because there is a rule you buy the indigenous one, but because you think the quality matches with the best from everywhere. Because you're paying a lot for the imported one.
No, I think there are several things there. You know, one is, of course, the price. The other is also a little bit of mindset, you know, because my students will always come and say, you know, the latest new compiler has come, the latest new, you know, multi-core machine has come, let's buy it. So I'm saying, you know, you look at all the features and tell me how many of them you're going to use on a daily basis. It'll be 10% of that, right? And so when we are looking at products, you know, if you're always looking at the best today, we may not need it. You know, sometimes I make this point about the defense purchases we make, right? I mean, is it that critical that you have that kind of advances, you know, when maybe you can innovate elsewhere, right? And not pay that kind of a price for that. So that whole aspect of what to buy and what to make is a very critical thing. And as you say, sometimes necessity comes in the form of, you know, outside bans and sanctions. So it helps us, right? And we are able to do a lot of things. And sometimes, you know, same thing happened with this thing, no, palm oil, right? I mean, India was well on its way to have indigenous oil seeds and, you know, oil industry based on that. And suddenly somebody decided, oh, palm oil is cheap in Malaysia, with free trade, let's do it. And the whole thing is now dead and buried. So, yeah.
Political decisions.
It's an issue, yes. It's a policy stroke technology,
Yeah. So I think the theme for 2022 on this technology day is very apt. Integrated approach in science and technology for sustainable future. And I think I didn't mention it in the very beginning as the theme for this May Day, but I think after all this discussion, I do think this theme is very, very apt, coming together, having an integrated approach, destroying all the walls between all the sciences, because all of us have come to a point where we have realized as individuals in a subject, you can just grow to a point, but can't take it beyond unless we come together, whether it's the physical, engineering, medical, and instead of only being users of technologies that came from all parts of the world, India has now got into the concept of making in India, creating in India, rather than only, creating in India, rather than only make in India. I think that is something Professor Gurumurthy has very well explained patiently to all of us. Sir, on behalf of everyone, thank you very much for your valuable time. And I'm just imagining if you were actually here, how it would be, but the distance did not make a difference at all, because you gave us that time and very patiently answered others' questions and mine as well. Without much ado, on behalf of Nitte deemed to be university, as well as the Technology Enabling Center of the Nitte University Center for Science, Education and Research, I thank you profusely and look forward to taking some of the technologies that are there in this university through the tech that we have to the next level. Dr. Karunasagar will be in touch with you for that, for help with whatever we think can go to beyond TRL 4 or 5, sir. And we need for that your advice on how we move forward. So thank you very much.
Thank you. Yeah, thank you very much for having me. And it was my pleasure. And as I said, I look forward to being there in person in the future. And all the very best and luck. And any help or assistance from our side, we'll be very happy to engage and collaborate. Yeah.
Thank you. Thank you very much, sir. Karun, would you like to say something?
No, I also would like to thank the Gurumurthy for his excellent talk. And we look forward to further getting support from you in various ways. We'll contact you. Thank you.
Thank you, sir. Yeah. Good day. Yeah.
Thank you very much.
Bye-bye.
Thank you.
Bye. Bye-bye. Yeah.